Well, we have the IOCCC prize in embiggening.
Now you say embiggening?
$5 word if I've ever heard one.
This is a perfectly cromulent and embiggened word. Embiggening. It's the act of cromulent embiggening. But who won the...
Well, who won the prize in embiggening? Well, let's embiggen their ego a little bit and find out.
And the IOCCC prize in embiggening goes to Ilya Kurdyukov from Russia.
So, congratulations, Ilya, for your hat trick. As is his third win of the night, and his would be his essentially seventh overall C contest win with a very interesting piece of code. And you'll see why we talk about embiggening in just a moment. Now, with this, let's look at how do you compile this code. It does take a math library. Ignore that a whining from the linker. It uses C99. This is a C99 thing, and also it's a O2 compile, which is another interesting aspect of this code. And this is what the code looks like. This kind of spirally bit of stuff. I will point out as well, you got this printf of printing some stuff out that might give you a little clue as to what might be going on, but not very much. All right. Furthermore, if you look at the thing Clang formatted, you'll see that it has this kind of interesting printf of what sort of looks like C, and that's important, and other writing stuff with some very interesting computation going on up here. This function gets called by main. You say, well, what's going on? What's next? Well, when you run this program and feed it some input like hello world, it produces a C program, which when you compile, prints hello world. If you give it something like, so if you look at this, as pause it in a moment here, you see it's got the prog produced C code, and here it is. And this C code is a bunch of variables, but no constants. There's no constants going on here. There is a write at the very end. And so this expression, prog took hello world and encoded it big to these variables, this variable, and this very complicated mathematical expression, such that when you write it out, you get hello world. Let's try another example. Moving on.
Oh, it's running a bit slow. That's why. And it slowed down because of later. Okay,
so let's pause it here. So what we did is we did an ls and piped the output of ls to program. It produced a different C program. Again, here you see the code that's up there, and you see that in fact it has turned around and it produced a even more complex set of expressions, and that constant set of expressions is then when you compile that, it's valid C code. Again, no constants. It's just straight thing. It does the final write, and that write will give you a output, and so it basically outputs the set. So let's take another example.
It's coming up. Here we go.
So here's a case where we take the program itself and print it out. So now what we're seeing up the top is like the last 10,000 characters, and you see that you get an even more complex expression. Again, look at all the variables going on in here, right? Again, no constants in there. It just at the very end does a write. So in this particular case, the C code is red. It turns embiggened into this piece of code which is around 10K in size. And when you compare the two, go a little bit farther, you'll see in fact that it fakely outputs things. So the next one, we feed it 64K of random data. So here's generate 64K of random data, feed it in, and produce this enormous source code that's 0.5 megabyte in size. And you're seeing real time, or is it sped up?
Right. Oh,
to compile that code.
Yeah, I can put it at real time here. We're at real time now. It'll take a while if I leave it. Here, let's go up to 400%.
Yes.
We're now at 400%.
Look at the variables and the expressions on these things. And as I say, it took about 40 seconds to compile this embiggened C code, which when you compare it to the original input is faithful, right? So this program takes input of any type and converts it into a mathematical expression without any constants and prints the result of that expression. And the output is the input. So, and it's a very interesting challenge for some C compilers because you try to optimize this code. It's got, for large amounts of non-trivial amount of input, it's got a non-trivial number of variables that are in these non-trivial expressions. And the compiler goes nuts. If you've got a compiler that doesn't do a good job of symbol lookup, it can become, and you've got some bad algorithms, you get to be quite quadratic or worse in its table lookups and symbol lookups. Some compilers can get quite unhappy if you're given a fairly large and big piece of code. Now, there's some challenges in the embiggening limit, and we offer as we call it a bug, but a feature to correct. When you get beyond about 100K, something interesting happens. And we left that bug in here because that'll give you an insight into what's going on. Also give you a challenge to fix it. But again, to see if you can get this thing to embiggen even more stuff.
Yeah.
Mm-hmm.
That in C, unlike some other languages, there are no keywords that consist of 2 letters. But there are some keywords that consist of 3, like int. So, the question is, how is that avoided?
Yeah, it does. It does avoid if and do, and those variable names, and so it manages to do some of that stuff. But there are some other things going on. So give it a try from when source code becomes available. Give it a try. Compile it and build a bigger piece of code. You'll see an error and it'll give you a clue as to what's wrong when it gets to be really, really big or really, really embiggen stuff. But it'll give you a clue as to perhaps how to fix that and move on. These larger pieces of code will challenge your compiler and certainly challenge your optimizer in very interesting ways. So well done, Ilya. A really impressive piece of code and really fun sequence that it generates to enter in its output. Thanks for watching. And before you go, please like and subscribe and check out the social media links in the description below. And if you like, you can support us on Patreon to help us bring you new content so you may enjoy our favorite universe even more.